to ways in which they can remain profitable while keeping their costs down. But also, we have to look after this beautiful earth we've been giving. And so, if we can go back to what was before with the help of technology and ensure that the sun, the wind, and all of nature can harness, will give us the energy we need to be able to drive economy, drive industry, and create wealth for the citizens of this world. Again, you're welcome. We'll be hearing from three experts who are well-versed in the space of renewable energy. And today we intend to ensure that as we all walk away, we'll learn a thing or two about renewable energy. More importantly, what that could do for our own businesses and how we can contribute in diversifying our energy sources to bring about efficiency in our business and also look after the earth as we ought to. We'll go straight into a very presentation. We'll be hearing from Leigh Naylor. Leigh is the Chief Executive Officer of Off-Grid Installer Limited, based in the UK. Leigh majored in engineering at University of Salford in the north of England. He started out as a sales manager, selling switchgear systems to major UK banks. And he also worked with large building projects, after which he worked in the solar industry. Now, Leigh and his team oversee installations and ensure they all maintain a high standard, with company achieving a 100% success rate. Leigh and his team have a combined experience of more than 30 years in solar industry. He's one of the longest standing solar engineers in the UK. And him and his company are offering a complete design solution and supply and installation services across international markets, including the Caribbean, here on the continent of Africa, and the Mediterranean. They also work with agents and contractors, across the globe, and they're able to work with local people within the countries to offer skill transfer and training, ensuring local ongoing support for their various installations. We'll also be hearing from Mark Barwick. Mark is an experienced sales and marketing professional with extensive experience in publishing sector, and latterly a background in e-commerce and asset-based finance. He has considerable experience in the marine conservation area, and in 2008 founded the ethical merchandise company, which is a finalist in Most Innovative Eco Business in the Digital Entrepreneur Awards of 2012. He's a veteran quartermaster with the Marine Conservation Charity, Sea Shepherd, and has completed several hours of duty. Mark spent 4 years as a committee member with the UK or the London Federation of Green parties as PR and press officer, and stood as councillor for the Greens in Richmond upon Thames. We'll also be hearing from Kofi and Ayeko. He's a technical expert with the AGI, which is the AGI Technology Center, Energy Service Center. Now, he specializes in the renewable energy and energy efficiency space. He's an engineer with experience in energy and the built environment industry, capable of leading successfully undertaking multiple projects at the same time, remotely or on-site with minimal supervision. He holds a master's degree in renewable energy and clean technology from the University of Manchester in the United Kingdom with distinction. Mr. Ayeko also holds a bachelor's degree in civil engineering from the Kwame Nkrumah University of Science and Technology in Kumasi here in Ghana. And he has experience as a project manager and an oil and gas downstream inspection and monitoring officer, and also a site engineer. So these are the three panelists or speakers you're going to be hearing from. We'll be taking questions at the end of each presentation for just 10 minutes. And then we'll have another window for Q&A after the third presentation. So in all, we'll have close to about an hour of questions. Each presentation will last about 10 minutes. after which we take the questions. We'll also have a survey question, which we'll be sharing in the link in the chat, and we'll expect that all participants will fill that out. It's important that we're able to understand whether this met your expectations, and if there are any changes that we need to make going forward so that these webinars and engagements are profitable for you in terms of the time invested, but more importantly, that you take away some very useful knowledge. We'll share that with you later. Without much ado, I'd like to hand over to our very first speaker, Kofi Ayeko, who is the AGI Energy Service Center. Over to you, Kofi.
Hello, good morning. Thank you, Insha, for the introduction. And thank you, UK Department of Business and Trade, for the opportunity to introduce our company and speak on this. As Insha mentioned, my name is Kofi Ayeko. I work with the AGI Energy Service Center as a technical expert in renewable energy and energy efficiency. And today I'm about to speak a little bit on the role of AGI-ESC in leveraging renewable energy and energy efficiency for business growth, mainly in the industry, but then we do it for both sides. So a little bit about the AGI Energy Service Center. The AGI Energy Service Center was formed in 2019 as a bilateral project between the German Development Corporation, GIZ, and the Association of Ghana Industries. The main reason why it was formed was to promote renewable energy and energy efficiency growth in the industry. But then with time, it developed, and it's more than just that. Now we offer consultancy services and advisory services in renewable energy and energy efficiency to both commercial and industrial clients. I'm going to use this short description over here, this building, to explain what the Energy Service Center is about and the kind of services we carry out. So as you can see from the building, the foundation says honest and independent broker. So as the Energy Service Center, we pride ourselves on being an honest broker. What that means is we try not to take services from the members of the Association of Ghana Industries. So for that case, what we do is we offer consultancy services to clients. And then in the end, if we can push those services, the implementation to our actual clients, we do that. The pillars of the Energy Service Center are technical advisory, knowledge transfer and public education, and financial advisory. In the next slide, I'll go more into details on the specific services that we offer to these clients. So the Energy Service Center, fortunately, we have a pool of experts, both international and national experts, for renewable energy, energy efficiency, and business development. And using our experts, we carry out the following services. The specific services for the commercial and industrial electricity consumers. The first one, we have solar feasibility studies. And with this, we come to your site and we determine the renewable energy capacity for your sites. Let's say if you have a factory, we come to the factory, we come and determine if you have the ability to have a good renewable system over there. Doesn't just limit it to solar. Sometimes it's biomass. It can be any other kind of renewable energy technology. The reason why it's important to have an independent feasibility study is that if you go directly to the service provider, it's more in their benefits to make sure you have the system. What we do is we let you know if it's even important to have a system. So that's a little bit of what the honest broker does. The second part is we do independent energy audits. With the energy audits, they are ISO 50002-2014 compliant. We do the 3 types of audits. Type 1, which is the walkthrough audits, the most basic one, up to type 3, which is the more comprehensive audits. Let's say if you have a specific system in your factory that you want to get audited, the type 3 is the audit for you. The third thing we do is we do training for commercial and industrial staff in energy management systems. Aside the training, we also do the implementation of the energy management systems, and we also help in getting certification if you require that. There's a common misconception about energy management systems. People usually just think it's a digitalized system. You just have to install some digital devices onto your machines and is able to have the whole system. But then it's not as simple as that. It's both analogous and digital. It's a process of 4 steps. Plan, do, check, and act. So with planning, you establish and review your energy strategy. You develop an action plan. When you come to the do side, you carry out the exact action plan. When it comes to the check, you're going to review your action plan using monitoring measures like audits, data loggers, and then you go to the act, where you actually feed insights from the checking side back to senior management for the cycle to continue. So that's about energy management system. So it's both ways. What we also do is we provide advisory support on renewable energy and energy efficiency investment options. With that, it's broken down further in the next line. Second opinions, transaction advisory services, which is more on the financial side, and owners engineering service. We also organize a lot of trainings at the Energy Service Center, mostly in renewable energy and energy efficiency. We do hands-on energy efficiency audit training for the service providers. When they come in, and we teach them how to actually carry out the energy audits, the ISO compliant ones. We teach best practices in installation and maintenance of solar PV. We realize that solar has a bit of a bad name in some parts of Ghana right now because some of the installers do not know the best practices. There are some common mistakes they do, and what we do is we try and educate them on the best way to go. We also do business development trainings for the RE and EE service companies. That one's a little more high level training. The last two things we do at the Energy Service Center is we do market analysis on renewable energy and energy efficiency in Ghana. And we also advocate for the adoption of RE and EE in Ghana and other things. So what our services have translated to. So you can see the training of energy service providers. We've organized a number of trainings and trained 278 individuals from various service providers. And we've also trained a lot of commercial and industrial companies, 157 individuals from 95 different companies in Ghana. Then the investment into renewable energy, over here, you can see what the services have translated to. So the project has supported the preparation of investments for 2.5 megawatts renewable energy. That's if they actually come. Not all the projects have also seen implementation, but then if they were to be implemented, it would be up to 2.5 megawatts. That can save up to 1,200 tons of carbon dioxide per annum. Investment into energy efficiency too, it's 1,360 megawatt hours per annum and 650 tons of carbon dioxide per annum. So with the second part of my presentation, I'm going to do a short introduction on what solar can do for your business. Okay, so I'll use an example for this because not all the factors are the same for every company. So let's say you're an owner of a company and then you have your production cost and your selling costs. Basically, in your production costs, a part of it is definitely going to be energy costs. So we're assuming 20% of your production cost is going to be energy costs. Once you get to the selling part, you have to add a profit on it. That's your profit margin. So we're also assuming it's going to be a 10% profit margin. Now, what we're saying over here is if you implement solar or any other energy efficiency measure, and you're able to save 5% of your production cost, that 5% that you save goes into your profit margin, supposing you sell at the same selling price. Now, it seems a little simple over here when you say basically, but then in the next slide, I'm going to show you how exactly that will translate into making profits. So this is a business case. Assuming we have two companies, company A and company B, who both sell a product. So forget the alcohol over there. Let's assume it's also water. Who also sell a product. The companies sell their product at 100 Ghana cedis per bottle in Ghana. The production costs, we are assuming they are the same, and both companies sell about 1 million bottles per year with an annual turnover of 100 million per year. So we also assume the profit margin as per the slide before is 10%. So company A and company B are going to run their businesses differently. Company A runs it conventionally and company B tries to reduce its costs via solar energy and energy efficiency. What you'll be able to see over here is company A has to make a turnover of 150 million Ghana cedis in order to make a profit margin of 15 million Ghana cedis. But then with the same amount of things, so the profit margin being 15 for company B, they have to sell fewer to make that profit of 15 million Ghana cedis. So company A will have to sell 50% more bottles to make the same profit as company B. Now, in highly competitive markets, company B will blow company A out of the market and they'll have everything to themselves. So what does this translate into? It will decrease your production costs, it increases your competitiveness, and improves your carbon footprint. Thank you. That's the end of my presentation.
That's wonderful. Well, thank you very much, Kofi and Ayeko, for that very concise and insightful presentation. We'll now invite some Q&As, questions on that presentation that was done. I have one of my own, and I think the privilege of being the moderator, I get to go first. But please feel free, use the webinar chat and drop your questions in there, and we'll be happy to put them to the speakers and get their concern. I see that the numbers in terms of the number of people who have received training and businesses is pretty good, because renewable energy is, even though we have the resources in abundance, the technology to actually harness it is where we are behind. Now, in a bid to leapfrog, of course, you'll need to make some investments in people and in the technology itself. Beyond these two, what do you think would be the one of the biggest hurdles, as well as the lowest hanging fruits, that you may set your sights on as a business? If there's a business out there that's looking to diversify their energy sources, where will their biggest hurdle be? How do they get around it? And where will their lowest hanging fruit be? And how can they take advantage of it?
Okay, thank you, Isha, for that question. So I'll start with the biggest hurdle first. For most companies that we deal with, the biggest hurdle is getting finance. But then I think what they don't realize is there are now a lot of financing options in the system right now. For example, solar energy. If you want to have a solar system, now there are multiple companies which can give you financing and also install it for you at the same time. There's something called lease to own. So with this, the installer or the service provider, they come and install the system for you. They take control of the system. Maybe you sign a contract with them, span over seven years. Maybe they give you monthly payments you're supposed to pay for that 7 years. What you might realize is that the amount of money you pay for electricity monthly might be what you'll be paying for those monthly installments. And in the end, after the 7 years, the solar system is yours. But then what we have to do is also to put these things out there a little bit more for people to know that there are different options for them to do when they want to get into solar or other energy efficiency implementation technologies. So with the lowest hanging fruits, what I'd say is it's the energy audits, type 1 energy audits. That's the most basic thing you can do. I'm going to give an example. There's something in most buildings, most commercial buildings, most industrial buildings that people don't realize. But their ACs, their air conditions. Most people have their ACs on 17 and 16 every day, is blowing all cool and everything. But then what you don't realize is the more different the temperature is between inside and outside, it makes the motors in the AC work a little bit harder, which is going to be pulling much more electricity. What we advise is that your AC should be around 24 degrees Celsius plus or minus 2, which is actually going to be time cool. What you don't realize is when you put it on that time, you leave it a little bit, it cools down. So those are some of the low-hanging fruits. When you do the energy efficiency, you find out those things. So thank you.
Great. And just by way of updates, we will be having the entire webinar hosted or published to the UK GCC, as the UK Ghana Chamber of Commerce YouTube page. So do well to find the UK GCC on YouTube and subscribe so that you get notified when content goes up. We're live on the UK GCC Facebook page. And for those of you who have joined us via Facebook, please feel free to also put your comments or questions in the chat on there. And we'll do well to pass the questions on to the various speakers that we have. So Kofi and Ayeko has just been doing a presentation on the importance of pretty much what solar could do for your business. Now, a lot of the time when we talk about renewable energy in these parts, we tend to think of solar first, because of course the sun is in great supply. Would you say that there is opportunity for other sources of renewable energy on the continent?
Yeah, there are other sources. There are opportunities for other sources of energy, renewable energy specifically on the continent. But then specifically in Ghana, I know there are opportunities for wind and biomass, especially. I think there's a lot of opportunity for that because of our waste, the kind of foods we eat. There's a lot of waste over there that we can use to produce that kind of renewable energy. Solar isn't the only one we should be looking at, but then the reason why we look at it so much is it's quite abundant over here everywhere we go. Wind is also being explored. I know there are some studies going on right now to determine where they'll be having the highest wind intensity. So we could delve into that too. But then when it comes down to industrial and commercial clients, they can't really look that far into wind. But then biomass is an option when it comes to that.
Great stuff. I'm going through this chat, and if you have any questions, please share them with us. Without any further ado, I'm going to thank Kofi for his presentation, and then we're going to go into our next presentation. If you have any questions, please use the chat box in the Zoom app and ask your questions. Even if the speaker has already finished speaking and we've moved on, do ask the question and we'll be glad to have them answered. Our next speaker is Leigh Naylor, is Chief Executive of Off-Grid Installer Limited, based in the UK. He's a man who majored in engineering in north of England. He started out as a sales manager. He's gone on to work in the solar industry, and together with his team, they have more than 30 years of experience in that space, and they believe also in knowledge transfer. So, ladies and gentlemen, welcome Leigh Naylor. Leigh, over to you.
Yeah, good morning, everyone. Thank you for attending. I apologise, I've got my Eskimo clothes on. It's very cold in the UK at the moment. I'm jealous of the warm weather, you guys in Ghana. I'm just going to share my screen with you if you give me a few seconds. Right, yeah, so obviously, oh, it's gone back already. So new possibilities for solar in Ghana. I think the market's come a long way by now, and I think Africa, has been a little bit behind in general in developing new solar fields and solar systems, and I think that now the price of energy has rocketed up, that I think a lot more people are aware that solar is a good possibility for their business. So I think the other speaker may have mentioned it, that solar now is probably one of the cheapest forms of power generation in the world, if not the cheapest, and also the most reliable. So what are the benefits of solar? Clean power, it's good for the environment. It is one of the cheapest forms of power generation in the world. It's been developed over a long period of time. The cost of the equipment has come down substantially in the last 15, 16 years. I've been installing solar. Also, the lifespan of the equipment, solar panels in general last 30 to 40 years. We say solar panels are going to last 30 years if you're near the coast, where you're going to get silt erosion, silt mist, which will obviously degrade the panels faster. If you're inland, especially in a tropical environment or somewhere like the UK, rainfall will obviously keep your solar panels clean. So you could expect up to 40 years life out your panels. All solar panel manufacturers now give a 25-year power generation warranty. What that means is that in 25 years, your solar panels will be producing between 80 and 85% of what they were producing on day one when they were first switched on. And yourselves in Ghana, you've got the luxury of having a lot of sunshine hours, 12 hours of sunlight per day, as you're near the equator. Okay, one of the other major benefits of solar is you've got a really fast payback on your system. I'll go through a basic example payback later, so you can understand exactly how much solar generates and how you'll get your money back. In the UK and the rest of the world, what a lot of people do, I believe the other speaker mentioned this earlier, you don't have to use your money. There's lots of people that will lend you money for solar because it is a reliable, technology that is industry proved that it pays itself back. So rather than use your own money, go and borrow some money off the banks and the system pays for itself in essence. The solar panels can be installed on roofs, on the ground. You can get solar tracking, solar installations. There's a wide variety of mounting systems for solar that can be used literally anywhere. And I know in Ghana, you have something called dumb saw. Myself, I went to Ghana 6, 7 years ago and I experienced this where the power goes down. I think you guys refer to it as dumb saw. And then all of a sudden you hear a cacophony of generators striking up in the background, and really solar and batteries is a way to minimize your use of generators. Okay, so I'm going to talk a little bit about battery storage and the benefits of that, and how you guys can get a benefit out of having batteries with your solar system. Okay, so obviously batteries are there to store any energy that you weren't able to utilize off your solar installation. So rather than give it back to the grid, or if you're in an off-grid scenario, there's nowhere for it to go, then the batteries suck up the additional juice off the solar. Another advantage in the UK especially, I'm not sure if it's the same in Ghana, but I'm sure you do have similar off-peak times. So let's say between midnight and 6 a.m. in the morning, you're able to charge up your batteries when the grid's giving you cheaper energy when everyone's asleep. And then your batteries can put that power back into your factory, your house, your farm, your hotel during peak times when the grid's going to charge you the highest rate for using the electric. So being able to utilize this, you can actually use your batteries intelligently, as well as storing energy in them during the day. You can get the batteries to charge during the night time when the grid's giving you off-peak electrical hours. Obviously, well, not obvious, but a hybrid battery solar system can be set up as what's called a UPS system. You've probably got something very similar, but a UPS stands for uninterruptible power supply, which means when the grid goes down, a static transfer switch would switch across in milliseconds. You do not see a power cut. The batteries kick in, and your power stays on without waiting for the generator to start up. Obviously, getting lots of power outages means your factory or your processing plants or your hotel is going to switch off while the generator starts up. So obviously this is going to cause out a factory shutdown for a short period of time. It's going to affect your production lines, and it's probably a very big irritant for you as well. Batteries also avoid the use of diesel generators, like I mentioned earlier. Rather than use a generator when you get a power outage, you can use your solar in your battery system. Batteries also give you, obviously, you're able to get the best out of your solar array. Like I mentioned earlier, rather than give the additional power back to the grid, you can store that for yourself to use an additional time. There's something called a containerized battery storage, which I believe the other speakers are going to speak about later as well. Off-grid installer, we have many manufacturers we work with. 90% of the lithium iron phosphate batteries, which are used for containerized battery storages, actually come from China. We work with multiple suppliers from all over the world, and we're able to give you between 1 megawatt and 3 megawatt hours of battery containerized storage systems. Okay, so here's an infographic of what a containerized battery storage system may look like. You can see you've got rack mounted batteries here. They look like computer rack mounts, which they effectively look like blade computers, but in each of those blades, there's multiple lithium iron phosphate batteries. The batteries come in different formats, whether it's a pouch cell, a cylindrical cell, which you might see in the Tesla batteries. 70% of all electric vehicles now use something called a pouch cell, which looks like a giant envelope. They're more popular due to the fact that they are more stable as a battery. Here you can see the inverters. These convert the DC power out of the batteries into 415 volts or 240 volt AC electric. Above these, you can see the DC solar to battery charge regulators. These little boxes convert the solar power from DC into the voltage that the batteries require to be charged. To the left of them, they are what would be called AC coupled inverters. So they're actually turning the DC electric straight into AC electric and pumping it straight into your factory, farmhouse, or hotel. To the right of the screen, you can see an example photograph of the system. So again, those are the rack mounted batteries there. Above those are the DC to AC inverters, and to the left of those are the DC to DC solar charge controllers, commonly known as MPPT, which stands for multi-power point trackers. So they track the maximum power point on the solar panels and operate to convert the best available solar power from the solar panels straight into your batteries. Okay, so where can solar be used in Ghana? It can literally be used anywhere. Standalone systems in factories. We've got a list here of typical sorts of places you would expect to see solar. I'm sure for the people that are watching, you know, you maybe have a large church that uses a lot of AC, air conditioning, maybe a farm that uses production, processing the plants, the crops. Hospitals is quite an interesting one. Obviously, if you're in the middle of an operation, you don't really want the lights to go out. It wouldn't be very good for the person being operated on. So most hospitals do have what's called the UPS system. We talked about that earlier, so that during a critical operation, the lights and the equipment being used doesn't switch off. Factories and warehousing. I'm sure there's lots of people who are watching today who've got factories, warehousing, and I'm sure these power cuts cause you guys lots and lots of hassle when these happen. Affects your production, affects your bottom line, and affects your ability to run the business in an efficient way. Mining, I know there's quite a lot of mining that goes on in Ghana, whether it's gold mining, copper or tin. I'm sure again, you know, a lot of machinery in these mines, and they're all using diesel generators, which is bad for the environment. So again, you know, by using solar and batteries, you're able to operate these places in a more efficient, quiet and cleaner for the environment. Okay, so here's an example payback. Solar in general around the world, it typically costs the same whichever country you go to. If it's installed, been designed, and you get in the equipment, the quality equipment, then as a general rule of thumb, solar costs the same in every country. It doesn't matter if you go to America or Africa or Asia or the UK. Solar costs between $900 and $1,400 per 1,000 watts of solar installed. So we're going to look at an example here. So we've got a small factory with a 50 kilowatt solar array or 50,000 watts of solar. This array would cost around $61,000 US. Typically, anywhere around the world or in the UK, that's what it would cost. The factory is going to use 200,000 units of electric per year. So that's how many units of electric it is actually using. A kilowatt of solar in Ghana is roughly going to generate about 1,300 units of electric per year. Okay, so we've got a 50 kilowatt solar array. Each of those kilowatts is going to generate 1,300 units per year. So we do 50 times 1,300 would mean that 50 kilowatt solar array in Ghana would generate you 65,000 units of electric. This means if you look at how many units of electric you're actually using, that means that 50 kilowatt solar array would generate you 32.5% of the power used in that factory. Obviously, if you wanted a bigger solar array, you go for 100 kilowatts of solar, and then you go up to 65% of the power used generated from your solar. I was looking on the internet to actually try and find an accurate cost per kilowatt of electric that's sold on the grid in Ghana. You may disagree with this figure here. This can always be changed, but I've got 13 cents per kilowatt hour of electric. So 65,000 units multiplied by 13 cents would mean that system would knock off your electric bill $8,450 per annum. So the cost of the system was $61,000, shared by how many dollars that system would generate you per year would give you how many years it takes to get your payback in Ghana, 7.21 years. So then you do 100 shared by 7.21 years, giving you a 13.852% return on investment. And that clearly shows that if you can borrow money from the bank at between 5 and 8% per annum in interest, it shows that solar will actually pay back itself, pay the loan back itself, and actually earn you money on top. And this proves that solar actually wouldn't cost you anything if you can get access to reasonable finance. Who are we? Obviously, I've already introduced myself. I've been doing solar for 16 years now. I've also done wind turbines and biomass boilers and heat pumps. But in the last 7-8 years, I have specialized, or we have specialized in doing off-grid solar power systems with batteries. Also do hybrid systems. So obviously got a grid connection and a generator. So if the grid goes down and the solar and battery still can't give you all your energy, then the system can still strike the generator up. That would be a hybrid system. The way we work, we design and supply and oversee local contractors to install the equipment. So in Ghana, we don't work for you, we work with you. We like to work with local guys, local people. We will send an engineer out to the project to make sure the system is being installed correctly, to train local people, and to do a knowledge transfer to the Ghanaians or the local workforce, so they've got a good understanding of how it's installed, so that after we leave, we're leaving expertise with the people that installed it. So if there is any issues, obviously we will come back as an engineering company, but there are trained local staff there to help manage and maintain the systems. Okay, so like I said earlier, I have been to Ghana. I went to Kumasi, Accra, Takoradi, where I was there seeing lots of different people and businesses about 6-7 years ago. Roderick Wright, he's also watching today. He's the international director of the company. Rod lived in Ghana for 15 years. He's got a lot of experience, a lot of contacts in the country. Spence Benafu is our agent on the ground in Ghana. If you guys have got any inquiries, you're likely to see Spence first. He's going to come out, do an assessment, speak to you, gather all the information, and be the middleman between yourselves as the client and ourselves. So Spence is like an employee really in Ghana of off-grid installer. We also have an electrical contractor. We have an electrical contractor who works with a lot of the mining companies in Ghana. Alex Bawang, I believe, is also watching today. So we do have an electrical contracting company who are very good. If you guys haven't got electricians or local people that can do the installation, we know Alex, we've worked with him. We know that Alex is very good at his job. In essence, you know, we've got a lot of knowledge in Ghana due to the people in the company, but our main purpose of working with companies in foreign countries is to do a knowledge transfer. So we're not just there to take the business, we're there to give back as well. So like I said earlier, we commission alongside local electrical contractors and your local employees or your maintenance staff in your factories. And that's how off-grid installer works. If any of you people have got any questions, please send them through. I'm happy to answer them. It is very cold in the UK today. I'm wet, so I'm a little bit shivering. But we do have our contact details there. There's lots of videos on YouTube where you can see different installations. And that's my end of my presentation. Thank you for listening, and I'll pass it back to Naira.
Wonderful. That was a pretty straightforward presentation. And as I did mention before we started, my bit of research on all the various businesses, I noticed in some of the testimonial videos. In fact, there was actually a video that was done in the British Virgin Islands, and one of the guys who worked with you on the project until you started that project had never done any electrical installation. And it's pretty nice to see the skills transfer, because oftentimes where you have people who have a situation where there is some new technology, it tends to leave the late adopters out to dry, because there's very little transfer of the technology. So that's great. There are a few questions coming through, and I would like to field some over to you for your thoughts. Now, Michael Mreku has a 3-in-1. The first one says, there's a perception that most renewable energy sources, especially solar, doesn't power high energy consumption appliances. For example, air conditioners. As we all try to get into the middle class, you're cold right now. Some of us are warm over here, and therefore we like to use the air conditioners. Talk about different worlds for different people. A second question has to do with, again, something which is still based on perception, that the leadership in the energy space generally is averse to propping up solar for fear that it will affect the demand on fossil fuel energy. So that if solar is that good, why hasn't been a governmental policy to actually whip it up to prevent doomsday, for example, as Leigh alluded to? And the final question, as he puts it, is that what is the role that industry expects financiers such as banks to play to grow the industry? So these are 3 questions that's just come through. Leigh's contact details are still on the screen, so please keep it there for now. So the somebody who wants to. So Leigh, you want to take those 3 questions quickly?
Yeah. What was the first question again? Sorry, was it about air conditioners?
So the first one has to do with the perception that solar can't power high energy, appliances. Like air conditioners.
No, that's a total misconception. Solar can power anything, a solar battery, generator system. Obviously, it's all about getting the right design, the right amount of batteries, the right size inverters, the right size of solar. If it's been designed correctly and installed correctly, solar can power anything. We do a lot of installations in the UK where we don't get the same amount of solar energy that you guys get. In Ghana, people can live totally off grid without the need of a grid or a generator in the UK for about 8 or 9 months of the year. So if that can work in the UK, where we get horrible, cold, grey, dark, wet winters, then I'm pretty certain that in Ghana, there's only when you get in the wet and rainy season, there might be like 2-3 weeks of the year where you're not going to get enough solar energy. Even on a day like today, I'm looking out the window right now, it's grey, it's overcast, and it's raining, okay? So when it's grey, overcast, and raining in the UK, the solar arrays will generate between 10 and 15% of their maximum. So a 50 kilowatt solar array is still going to be giving you 15 kilowatts of solar, even on, sorry, not 15 kilowatts, 7.5 kilowatts, 5 to 7.5 kilowatts solar power, even when it's raining, grey, dark, and overcast.
Well, good answer. There's a second question which I think I would like to throw to Kofi, largely because Kofi's space that puts him, in contact with policymakers here. It has to do with, that if solar is that good, why aren't we seeing governments push an agenda to make solar a mainstay and something that everybody can, afford? Kofi, would you like to try a hand at that?
Okay, yes. Thank you, Inshira, and also thank you, Michael Mreku, for asking the question. First, I'd like to add something to the first question he asked about the misconception. Yeah, it is a big misconception that solar cannot power some high-consuming equipment, and this is why it's also important to undertake the feasibility study. Some people let's say in the local space in Ghana, they just know that they want to get solar, and then they get an installer to come and put something on top of their roof without knowing what they consume or how much solar capacity they even need. So this is why you need to do a feasibility study first to determine how much energy you're consuming, and then to know what you are going to put on the solar system. The person who does the study would size it appropriately to meet your demand. And with the second question, yes, it's true that it seems things are moving a bit slow in the system, but then to my understanding, I know through the Ministry of Energy and the EC, the Energy Commission, there are a couple of things that are being put in place to make sure solar is pushed much more. But then they are a little bit handicapped because of the PPAs that were signed some years ago, the power purchasing agreements. They were signed during the doomsday period when we needed light immediately. So with those, there are long-standing agreements that we'd have to adhere to. So if they fully allow solar to take over right now, it might be difficult for them to honor the long-standing agreements. But then, notwithstanding that, I know there are a lot of things moving right now. Hopefully this year we'll see. There's net metering coming up and a few other things. So yes, I'd also type a short answer to what you said. Thank you.
Thank you very much, Kofi. A couple more questions. So this has to do with the UK's role in promoting the rapid application of solar systems as a capital cost relatively high. I'm not too sure who would like to attempt to answer this particular question. And,
what was the question? Sorry.
Yeah. So the question says, what has the UK done to promote rapid application of solar systems as capital costs are relatively high?
How has the UK promoted solar? Well, I think the UK started, obviously, to start with, created a solar industry in the UK by, it started with something called the feed-in tariff, which was a government subsidy. Obviously, there was nobody in the UK with any knowledge of solar really up until 15, 16 years ago. I think the leading European country was Germany initially, that started the solar revolution in Europe, and that's quickly progressed to the UK. So it's the same in every country that is starting renewable energy. It's all about knowledge and skill transfer. And the UK's a country that's a very big believer in education. So, you know, the fact that I'm here today doing a presentation from another part of the world to Ghana, I think proves, you know, that we are here to help you guys with knowledge transfer to get your industry going.
Great.
Can I also come in, Inshira?
Yes, shoot.
Okay. Thanks, Inshira. So in relation to the UK's involvement in promoting solar in the country, for the Department for Business and Trade, we are able to support this by providing a sort of investment and sort of guarantee for large-scale solar and renewable energy projects. For instance, we partner with export credit agencies like the UK Export Finance and BII to help support some of these large-scale projects to help bring about renewable energy projects in the country. So I think that also answers a bit of that question as well.
Great. And in case you're wondering who you just heard, that's Michael Taabavi. He's the energy lead at the UK DIT. So he had to step in with that answer.
Could I step in as well there with perhaps another response and some lessons to be learned for Ghana from the UK side of the solar, that whilst there's investment within the UK and there's lots of opportunities, as Michael's alluded to, one of the biggest obstacles for solar in the UK is actually the DNOs, or the distribution network operators themselves. So solar has a massive opportunity within the UK, but we're constrained by the grid operators who dictate the size of the solar system that can be installed depending on its output back to the grid. So if the grid in that particular area can't cope with the supply from the solar, they will restrict that supply from the solar capacity. So, for example, you may have a roof space which could produce up to 1 megawatts of solar, but the connection within the local distribution area can only handle 500 kilowatt hours or 500 kilowatts of output. The DNOs will say that you can only install half the capacity within your space. So there's no reason why that solar panel, the solar capacity, can be to the full extent that could be available, and that additional energy go into battery storage. So there's some lessons there to be learned for Ghana, I think, is that don't concentrate just on the outputs back into the grid. put any energy that is excess or can be produced back into battery storage and feed the grid from there.
Great, thanks very much for that input, Mark. You'll be hearing from Mark in the next presentation. We've got about 3 minutes to wrap this segment up. There's a question from an anonymous attendee, and this question was directed to Kofi, but by all means, Leigh, do step in if you would like to contribute. But this has to do with the scenario of the fully owned system that starts off as a lease to own, another lease to own way of ownership or route to ownership. Now it says the system will be fully owned by the client after 7 years. And if so, that means that the client has about 3 years before major maintenance of the system. And if that's correct, the concern has to do with inflation. Now, of course, there's issues with currency exchange, an exchange rate that most Ghanaians will worry about. No matter how beautiful a solution is, the concern will be how the cyclical jumps in currency exchange rate affect what we spend and how we spend on things. So if a person owns their system after 7 years, and then they're just 3 years shy of a major maintenance, the worry is, how do you ensure that by the time you have full ownership and fully responsible for the maintenance, you're not suddenly out of pocket trying to keep the system going?
I'd like to jump straight in there. I can tell you now that 7 years, in my experience in the UK, that solar doesn't really require a lot of maintenance. The panels will self-clean when it rains, as long as they're more than 12 degrees inclination when it rains, all the dust is washed off the panels. So that's the major maintenance really for solar panels. The weakest link in solar is always going to be your power electronics. I've seen inverters still going after 12, 15 years. The inverters really are quite cheap to replace, but I would say that everyone throughout the world at the moment is seeing a high rate of inflation, including in the UK, which is about 10.5%. With inflation comes increased cost of electric. As the cost of electric goes up, your return on investment on your solar system will actually increase because you're offsetting a bigger portion of your electric bill. So actually, the inflation and the increased cost of electric actually has more of a proportionate response back on your payback of a solar array.
Yeah, thank you, Leigh. I'll just add a little to what you just said. It's also a good question. When I said 7 years, it was just an example. The lease to own could go as long as 15 years. So that, the service provider is going to take up maintenance till they hand it over to you. And as Leigh said, solar doesn't give up that easy. It's actually very long term. So it's not going to be a problem. And with regular maintenance throughout the lease to own period, you wouldn't necessarily have to undertake a major maintenance after 10 years. So the clients will definitely benefit.
Great. Another question that Kofi has already answered had to do with companies in Ghana who provide, the energy solar solutions. And that's available on the Energy Commission website. So if you're looking for that, you can go to www.energycom.gov.gh, and you should be able to find licensed entities who can give you safe solutions as far as solar is concerned. Final question: how many hours off grid are available for solar? And I know, Leigh, you mentioned that we're close to the equator. In fact, we are the closest to the equator. So we are the center of the world, so to speak. How many hours of solar can give someone complete independence off the grid?
Sorry, I missed the last part. Can you say that last part?
How many hours of solar is required to keep someone completely off the grid?
Again, that's down to the size of your solar array and the size of your battery bank. The more solar panels you've got, the more solar energy you're able to capture. The bigger your solar array, obviously the bigger the battery bank you have, the more energy you're able to store. So it's all about the design, is looking at the total loads, how many units of electric, a house, a factory, a school, a hospital uses over on a daily period. And that's where you start your design. You're looking at how many units of electric someone's using. Is it a single phase? Is it a three-phase connection? Obviously, that you're then looking at the size of the inverters, so they're able to give the peak loads over the night or the daytime. You might get a peak load in a factory when all the electrical motors, etc., are starting up. So there's quite a few areas of detail you've got to look at. And obviously, I know Mark broached on the subject earlier about grid limitation systems. One of the things we do is what's in the UK is called a grid export limitation application. So if the grid gives you a kilowatt peak that you're not allowed to export past that, it will actually limit the amount of power that will be exported back to the grid. At the same time, an ESS system, energy solar storage, is able to use the grid's power for excess peak loads. So if you've got a 15 kVA inverter, you're actually able to get 30 kVA with a grid there. So for high peak load demands, the peak load can come off the grid. And the main demand during the day can come from the solar batteries and inverters. So it really does all depend on how you've designed your system, who's designed it, and what equipment's been installed. As Mark probably tell you, there's lots of different equipment available on the market in solar. From my experience, there is lower quality equipment. We've only ever stuck to the top 10 solar panel manufacturers in the world due to warranties, etc., quality, the manufacturing, how the panels have been produced, but also the reliability of the equipment. And at the end of the day, you know, power, electrical power, as everyone experiences when they get a power cut, it is a big pain. And if you're going to invest that sort of money, then you want something that's going to be reliable.
Great stuff. Thanks very much. This brings us to the end of the scheduled Q&A. We'll have another set of Q&As after the final presentation, which will be done by Mark Barrick, is the lead business development for ZPN Energy. And he's an experienced sales and marketing professional with extensive experience in the publishing sector, and latterly a background in e-commerce as well as asset-based finance. Now, Mark joins us with a great deal of expertise as well as a passion for renewable energy. And so I'm going to hand over to Mark at this point for his presentation. Keep your questions coming. I've got a few more to go through, and then when we get into the general Q&A, we'll field those. A very interesting one about the Internet of Things and solar. That's something I would like Leigh to pay attention to when we come to it. So Mark, over to you. And then at the end, we'll come in and take some more questions.
Thank you very much, everyone. And it's a pleasure to be here. And I hope you can all see my screen clearly there.
Yes, it is. That's fine.
Fantastic. Wonderful. Thank you very much. So we're experiencing an exciting transition period at the moment in a new area of production of energy distribution, but also the field of e-mobility as well. Now, with that transition and new opportunities, there are also some areas that can be problematic as well. Those problems can be constrained energy supplies, rising energy costs, particularly relevant here in the UK, and I suspect probably will be within Ghana as well, is that there's a poor EV charging infrastructure. So whilst in the UK we're heading for a race for more and more EVs, there's not really the infrastructure or the charging infrastructure to support that expansion of EVs on the road. Now that's causing range anxiety for EV drivers, but also areas where there's rural locations, that could be grid infrastructure problems in feeding those EVs. So at ZPM, we like to concentrate on solving those problems and providing a turnkey solution rather than an individual product solution. Our solutions focus around the areas of EV charging, storage of energy, grid enablement, business support, and also home support. So we like to concentrate, I guess we see ourselves as an energy vector we focus on harvesting of energy from whatever source that be. That can be from the grid, that can be from renewables, could also be from a blend of grid and renewables, storing that energy and delivering to either EVs, businesses, or to homes. Now, our hubs EV charging solutions are rapid DC chargers. We don't produce 7 or 22 kilowatt or AC chargers. Essentially, with EV charging, particularly if you're operating as a commercial operation, you're really selling time. So why would you install a 7 kilowatt charger when you can install a 50 kilowatt rapid and get more of a dwell and more occupation on the charger, and therefore increase your revenues? Our hubs chargers were one of the first globally to be accepted of the OCPP 2.01 standard, and we've been PAS 1899 compliant since 2017. Now, PAS is a new standard just introduced in the UK, and within Europe will probably be adapted as well. And that standard, or the guidance, will focus around accessibility of the chargers, particularly for those who are disabled. Our hubs chargers are innovative in as much as that between the power supply and the charging head, we place battery storage. So that means that you will always get a consistent supply of energy, depending on whether whether you've got a low grid connection. Now, this was first implemented in Heathrow Airport in 2017, where we were charging up to 168 electric taxis per day from a 150 kVA power supply. Now, that would barely charge or be able to run one 50 kilowatt DC charger, but we had 5 50 kilowatt DC chargers connected, as well as 15 22 kilowatt chargers as well. Now, particularly relevant, I should imagine, in the areas of Ghana, particularly in rural areas, is our ZapMe mobile charging service. We were the first globally to adapt this service, and it's essentially the battery storage from our hubs chargers connected to a charging head and with charge controllers, and put into a back of a van or any vehicle. So that means that you can take the charge to your customers wherever they're located. So that can be particularly useful for EV recoveries, out of charge EVs. One of the learnings in the UK is that when EVs run out of charge, you can't put them into neutral and push them. The wheels essentially lock up. So you're dealing with a brick essentially that can't be moved. And the only way of moving that vehicle is either to bring in a high lift vehicle with a crane on the back and put onto a flatbed and remove it, or to charge it on spot. Now, our solutions come in various standards, sizes from 50 kilowatts, from 10 kilowatt hours of storage with 50 kilowatts of output, up to 150 kilowatts of storage and 150 kilowatts of output. Aligned with this is, as well as on the charging side, one of the areas that we don't know about EVs yet is kind of what we don't know. There is new technology, it's advancing rapidly. So the more insights that we can get into how EVs operate, what their charge rates are like. There are a lot of manufacturers and OEMs making wild claims in terms of range and capacity of EVs, but EVs are very much affected by temperature ranges. So in the UK, on a cold day and a wet day like today, your range capacity can be decreased by as much as 10 to 15% just by the weather. So the more insights that we can get into how an EV is performing in real time, this is particularly useful for fleet operators and fleet managers. This enables them to have live information from their vehicles which are on the road at the time. So if we can imagine a scenario where there's a cold day like today in the UK, a vehicle will set off in the morning with potentially 60, 70 miles of range. As the temperature increases and the load is decreased from the vehicle, if it's a delivery van, for example, is dropping off some of its round of routes, then that capacity or the range can increase from 50 to 60 up to 70. And our system enables fleet operators to get that real-time information to be able to book in other loads as and when needed. One of our other areas is the storage of energy. Our ZPN stores can be configured in solutions up from 1 megawatt up to 3 megawatt hours of storage. And that's essentially containerized storage, which sits in a standard ISO container and can be located in any location and hot swapped in and out as and when required. So these can either be permanent solutions, which are connected to renewables and harvesting from there, providing additional support and grid support, or these can be pre-charged solutions, which are dropped into place and replaced and replenished as and when needed. Now, this is particularly relevant to rural locations or for emergency power supplies. Our energy management systems control all of the software. It's intelligent software which controls our energy storage and delivery solutions. So we can support grids with combination of energy sources from either sleep PPAs or feeds from solar, wind, and other renewables, as well as from a grid support. As Leigh alluded to earlier, that this grid support can actually support the grid, as well as actually times of peak supply, be able to supply power back to the grid, but also in terms of when there's an additional demand on factories, for example, you can pull power from the battery storage as well as from the grid as well. And just a little case study of an application of our energy storage solutions and our turnkey solution. We have a large national company within the UK called Nationwide Platforms. They provide access solutions, cherry picking solutions, and access lift solutions to businesses. They operate in multiple locations around the UK, and they have to be in industrial areas because of their client base. And usually their depots that they operate from will be power constrained. Now, this particular case was an example from their West London branch, just around the corner from Heathrow Airport. They're having an increasing number of their platform solutions are becoming electrified and transitioning from diesel or petrol powered plants. And as a result of that, the charging demand that's based on their depot is increasing. Combined with this, that they have recently taken on 2 electric trucks to replace their diesel fleets. One of the issues that they had was the capacity, or the electricity capacity at the site is probably already at 85 to 95% capacity. At times of peak supply or peak demand, they're reaching power outages and trip rates from their power distribution boards. The issue that they had at Nationwide is that the distribution network operator or the power supplier within that regional area wasn't able to upgrade their grid connection. They made a request to have an increased power supply. The estimate on the cost for that was at £2 million, plus a wait time of 2.5 to 3 years. So Nationwide come to us to find if we could provide them with a solution. And that solution was to put in solar PV canopies in the areas where they are currently storing some of their plants. The solar output from their existing building and their depot wasn't enough. So we needed to input solar canopies to be able to supplement that or provide the additional output of solar PV to support their power demands. The energy generator there was fed into power supply, and that was able to support the depot, their EV charging structure, as well as charging their trucks and their customer cars and their staff cars, as well as the plant as well. This is just an indication of some of the return on investment. Now, combined, the return on investment from just solar installation and battery storage alone and their energy saving costs was 6.47 years. But combined with the fact that operationally, they needed this, this solution to be in place immediately. They had a 2.5 year to 3 year waiting time from the distribution network operator to be able to upgrade their grid. And with a combined cost of up to £2 million, once you take that into account and their operational benefit as being able to install this system, this brought the return of investment down to 2.72 years, so just under 3 years. And I think this is a pretty compelling case for energy storage and solar PV. So thank you. That's the end of my presentation, and I'd like to ask for any questions, please.
Fantastic stuff, Mark. That was really good. EVs are beginning to surface here in Ghana, so it's quite interesting to see that there are solutions in that regard. I'm going to jump into the questions now. We've got quite a few here. So Gilbert says, one question that emerges from ordinary and potential users of solar is, how do countries that encounter snow continue promoting solar systems, unlike countries that experience longer periods of sunshine? Very paradoxical indeed. What do you make of that, Mark?
Yes, we're seeing some interesting statistics. We've just had a recent inquiry with from Iceland, and we're looking at a solution there. The issue with snow, yes, it will restrict solar PV output. So obviously those panels need to be kept clean, but there are usually in countries like Iceland, there are other solutions that can be combined with in terms of the power generation. So that in areas like in Iceland, countries like Iceland, they've got a lot of geothermal possibilities. So we would take power supplies from geothermal sources as well as wind, and additionally biomass plants as well.
Great. Now, there was a previous question that all three of you can dive into if you find it in your space. Rhoda Andor says that we ran a construct and refurbishment business. We have decided as a strategy to install solar plants instead of diesel power generators for the homes we work on. The challenge now is gaining access to solar contractors is difficult. What can we do to improve the knowledge and visibility of solar powered generators in the country? That's one question. And then the second one is directed at Leigh, but you can all jump into this. There's a convergence of technology where the Internet of Things is being leveraged on pretty much everything we do, and solar is not an exempt. Could you share with us what some of the applications of Internet of Things are in bringing further efficiency to solar? So these are two questions. One, what can be done to improve the knowledge and visibility of solar power generators in Ghana, and the benefits of using what's now called smart solar grids?
Sure. So I think I'd like to jump onto the second question first. Smart grids and the Internet of Things is obviously having a massive impact on energy storage and production as well. So it's one of the areas which we're focusing on at ZPM, both domestic solutions, but also commercial, particularly relevant on and applicable in the UK for the home solutions with energy rising or energy costs rising in the UK, is that output of solar PV at the moment, as I alluded to earlier, is restricted by distribution network operators. So there's no reason why solar arrays on domestic properties can't be sized larger than the DNOs stipulate and dictate, with that energy feeding into energy storage and battery storage solutions. That battery energy storage solutions can not only power the house and the domestic application, but also solutions which we're looking at is powering EV chargers. So rather than having a slow charger at home, a 7 kilowatt charger, which would take, with most EVs at the moment, 12 hours to charge a vehicle overnight, with increasing range and battery size of some of the EVs coming on the market, that 12 hours can, in some cases, become up to 36 hours of charging from a 7 kilowatt charger. So rather than having a 7 kilowatt charger, if you combine the battery storage, you could have a rapid charger and a 50 kilowatt charger within your home. So rather than that 12 or 36 hours to charge your car, you can charge your car in 40 minutes. So that could be particularly useful in situations where you're an on-call worker or a doctor, for example. If a doctor is driving home, parks up his EV and is charging up and then gets a call out, he doesn't want to wait 12 to 36 hours for his vehicle to charge. He's going to get out immediately. So that convenience of having a rapid charger at home, where the Internet of Things comes in there is that our software solutions can predict sunshine rates and weather patterns and auto charger and storage outputs and inputs accordingly.
Thank you, Mark. I think I'll take Rhoda's question then. I see Rhoda's question as in two parts. The first thing, she said she has challenges in getting access to solar contractors. So as we said earlier, and Ishra shared, the Energy Commission has a list of solar service providers, and that list you can look at and try to get from. The second thing you can also do is from the Energy Service Center, you can come to us, and then through our transaction advisory services, we could help you find a suitable contractor for your services by helping you out with the tendering process. If you also want us to do the feasibility for you to determine how much you even need before we do the tendering, we can also help you with that. So yes, you can get in contact with us for that. And I think the second part of Rhoda's question. Sorry, Ishra, can you please read the second part of Rhoda's question again?
The second part of Rhoda's question had to do with, just give me 2 ticks. Right, so what can we do to improve the knowledge and visibility? That's one part. The other one is, it's, so how do we improve the knowledge? But she does have a second question, which maybe I should just put out now, which is that the impact of charging batteries on your electricity bill. You know, what other the concern one project owner raised with them was that, was it going to increase their electricity bill? You know, and was this person better off using a diesel generator? I'm not sure what the configuration of that project was, but this was a question that came up.
So in terms of improving the knowledge and visibility of solar power generators in the country, it's an ongoing topic. At the ESC, we are trying to push that more through our website, ESC, AGI-ESC.com. We are also going to undertake some mass media exercises to push that further, because without that, I don't think we'll be able to educate a lot of people on the importance of solar power generators. People just know about it, but they don't know, let's say, even the basics. They only know that solar is from the sun. But to know how to access it, who can help them do it? Even the list of the Energy Commission, I'm sure a lot of people didn't know that, but it's public knowledge. It's there for everyone to access. So I think the main thing will be mass media to try and push that. The second part of her question, one owner raised the question that it was going to increase his electric bill, so it was better off using a diesel generator. I don't think that is absolutely correct. It depends on the type of system. You know, there are hybrid systems with a solar installation, or you could go fully on solar as a standalone system. So depending on what is charging their batteries, you can either charge your batteries fully with a solar, or you can charge it both ECG, that's the electricity provider in Ghana, or solar. You can do a hybrid. So if you go fully on solar, you wouldn't have to charge your battery and it wouldn't affect your electricity bill. But if it goes hybrid and you also want to be charging your batteries with ECG, depending on how big your battery is, it's going to pull that. So that is how it affects it. So I don't think the person would be better off using diesel generator, not cost-wise because of the price of diesel in Ghana now, and also because of the emissions that's going to be generated. But that's my answer to that. I don't know if Mark or Leigh has something to add to that.
Can I answer those 2 questions as well, please?
Yeah, sure.
Yeah, I would say by increasing not just contractors by mass, but contractors by quality. And I think the only way you're going to get that in Ghana is by introducing companies that have got experience and knowledge base that we can pass on to the contractors in Ghana to build up an experienced level of installers in your country. So the main answer to the first question, I would say, would be education. There's got to be more training. There's got to be more education. There's got to be more skill and knowledge transfer to the contractors in Ghana, so you're getting quality installations. Because if you don't get quality installations, it's going to produce bad feedback for the solar industry, and it's going to not encourage more people to take solar and battery storage up. Okay. The second question, which is related to is it smart energy networks and why not use a generator? Clearly, a generator requires a lot of maintenance. It's noisy. You may not be able to get the diesel when you need it. It may run out of diesel when you really need the generator. By having solar, it doesn't make a noise. It doesn't have any moving parts, and it's generating even in low level light. Okay, so by having a decent battery energy storage system, you're able to store that energy and use it when you want. Yes, it's going to cost you money up front, but if you look at the payback calculator of running a property, a business, a factory off a diesel generator, which I believe at the moment with the increased cost of fuel is around $70 per kilowatt hour, as opposed to nothing off your solar panels once you've paid for them. You don't have to put fuel in it. The fuel is coming from the sky. So your payback versus a diesel generator is about 2 to 3 years. So if you want to run off a generator and then convert to solar and batteries, you're looking at maybe with batteries 2 to 5 year payback. So a 20% return on investment is definitely an inflation beta, shall we say.
And I think there's that maintenance issue there as well, Leigh, is that a lot of operators of diesel generators within the UK there's not that the operator ability, if you like, so that a contractor will come in and put in a large-scale diesel generator. So you've got the fuel costs there and the maintenance costs, but also the operational costs that many consumers or customers of diesel generator companies, that once the operator will come in and start up the machine, and then the machine will run until it's turned off, usually by the contractor. So it's producing power all the time, regardless of whether the demand is there. So with solar and energy storage, then that the power is going to be fed into storage and used when you need it, rather than a diesel generator, which is running constantly, burning that power all the time and burning fuel, producing output regardless of whether it's required or not.
Absolutely. I mean, when I was in Ghana, one of the experiences I had was looking at all the diesel generators that people were using. And generally, people size their diesel generators incorrectly. They think they need the biggest, largest diesel generator they can get their hands on. If you run a diesel generator at less than 60% load, you're going to glaze the bores on the diesel generator. That diesel generator is going to have lots of problems with it. It's going to start leaking oil. All the seals are going to break. Your diesel generator will not last very long. So sizing a diesel generator, there is a bit of science behind that. But from my experience, what I've seen, including the UK, is that people buy a too large a generator than what they need. So they don't last very long, and they're spending a lot of money fixing them all the time.
Well, with that in mind, one is now going to be minded what choices to make, especially where you're looking to keep your cost low and your efficiency high. Gilbert Kofi Salome sends a note to say that he doesn't think that his question was adequately addressed, as it focused on solar and not alternatives. Now, I think the question had to do with what are the alternatives for spaces where some time of the year is quite cold, and therefore you're not going to get as much exposure to sunlight as you would. What other alternatives in the spectrum of renewable energy could be deployed in, for the lack of a better expression, downtime of solar?
Wind turbines.
Okay. I hope that answers.
Yeah, and I think it doesn't need to be an individual solution or an individual alternative. The beauty of battery energy storage systems, when combined with solar and any other renewable, is that there can be that blend of multiple inputs.
Great stuff. A few more questions. Now, this is quite technical. So it's from Winam Wilberforce, or Winaman Wilberforce. Says, is there an inverter that can convert 12 volts from my solar PV to 11,000 volt for my transformer? And yeah, the second question is from Bright Apple. Bright says, what is the latest solar panel technology? And then a third question, so you guys can choose which one to. If an engineer wants to be trained to benefit from the knowledge transfer and to assist with installation work here in Ghana, what is the process? So these are three questions. Who wants to go first? Leigh or Mark or Kofi?
I'll answer the first question. I don't believe there is an inverter that will convert 12 volts into 11,000 volts. That would be a bespoke transformer of some description. I don't really understand his question exactly, but if you'd like to send us detail of what he's looking at, we might be able to help him and come up with a technical solution.
Super. There was one. Yeah, Kofi.
Yeah, I'll take Bright's question. What's the latest solar panel technology? That's a very difficult question to answer. I'm going to assume it's gone up.
That's fine. You're still here. We can see you and hear you.
Okay. Sorry. So it's a bit difficult to answer because every day, you know that we are in the lab trying to develop new technology. What to my knowledge, perovskite cells seem like the future. Perovskite cells and then ultralight fabric solar cells. So those are the two latest solar panel technology. Bright, as in.
Great. Julius's question on how does one harness their interest to gain more knowledge and training in the space of knowledge transfer as far as installations are concerned. Kofi, is there something that the AGI is doing that maybe the likes of Julius may be able to take advantage of?
Yes. The AGI is always organizing various trainings for not just experienced service providers, but for people who are now trying to get into the space. The main things we do, especially the energy audits, the type 1 trainings, are for beginners and also for experienced people, because you can never really know too much. Some of those who come, it's their first experience with energy efficiency and even solar, but then they're able to learn something and then they jump into the space. Another benefit from joining our trainings is that when you come, you're able to meet more experienced people. You form a connection. We usually, after each training, form a group or put you in a group of past students, past participants, and then you can form an alliance. You get to learn from them. Some of the people end up getting internships and learning more. I think what he was also trying to find out was if I think either Mark or Leigh mentioned about how it will be beneficial to have international solar service providers in Ghana to also show their input. I think he's trying to find out how that will be possible, how the process he had to go through to get that experience. So if Leigh or Mark can take that part.
Yeah, sure. I'd say getting involved with an actual installation with us. When I did the job in the British Virgin Islands back in September, Blues was from St. Vincent and Party was from Jamaica. They'd never done any solar before. They helped me assemble all the batteries and wire them up. I was showing them how to do that. I was showing them how to fit the solar panels on the roof. Once they understood what they needed to do, I could leave them to it. And it's really just getting involved. It's like anything, practice, you've got to be part of an installation, got to be part of the design, understanding what information you need in order to be able to design a correct solar system. All the basic things really, but yeah, getting involved in the whole process of extracting the right information to why we're putting forward a particular design to then getting involved on the installation of the system.
Mark?
I would agree with everything Leigh said there. Yeah, there's no sort of alternative to getting involved and really just reaching out to organizations like Leigh's and us that are working within Ghana and getting involved with us and learning from that experience.
Great stuff. There are still a few more questions. Now, I think Winterman's just come back. I don't know whether this is something that can be attempted here or if we would consider an offline chat on this, because his statement now is that my load is 3,300 volt rated. How do I supply my load from solar?
What's 300 volt rated, sorry?
His load, it says my load is 3,300 volt rated. And he wants to know how he can supply load from solar.
Okay, so solar panels generally are around 40 volts per panel. So when you add up solar panels and a string of panels, you normally a maximum around a string of 25 panels in a string, which is giving you 900 to 1,000 volts. Okay, so we've got multiple strings of panels at 1,000 volts that are feeding back to AC DC or AC inverters. AC is alternative current, DC is direct current. So again, batteries, typical voltage battery for a small off-grid system be 48 volts. But again, you can series up the batteries to give you the voltage required. And then the box of tricks in the middle, which gives you 11,000 volts kV, is called an inverter. That would turn the DC power into the AC power. And then after that, you could get something called a step-up transformer, which steps up a lower voltage into a higher voltage. So you would need a 240 or 415 volt step-up transformer, which would step up your voltage to a higher voltage, which would then power your equipment.
Okay, well, for more answers in great detail, I think that it would be good to connect directly with the speakers. I believe that the team at DIT will be sharing contact details with the participants. Now, the comment here from Gilbert says, in terms of emission of greenhouse gases, I think that there is the need to promote solar systems as against non-renewable and even some renewables such as anaerobic digestion, which mitigates but doesn't totally eliminate emission of greenhouse gases. Now, that's a very interesting point he raises. Gentlemen, I'd like to get your thoughts on that. Okay, so if there are no immediate takers, let me do an eeny, meeny, miny, mo. Okay, Kofi, your smile is broader than everyone else's, so you start.
Okay, yeah, I think it was more of a statement than a question. Speaking about how there's a need to promote solar systems more than the other renewable energy sources, which is true. I think we all agree, and that's one of the main reasons we are having this webinar, to promote it a bit more. And the whole thing is that sometimes when you look at the entire cycle of production and you go very deep into it, you might find out that even in producing the solar panel, there might be some emissions. So it's difficult to have no emissions at all. Yeah, that's now still being developed. So maybe you go to the power to X and the other kinds of technology coming up. But then at the moment, the systems we have, there will be at some point of the value chain some emissions. So as he said, though, solar right now is the best thing we are pushing for. I don't know if Mark and Leigh have any other things to add to this.
Yeah, I would agree that in the UK, one of the probably least carbon intense outputs from renewables that we have is probably wind. We're looking into other solutions such as waste to energy as well. Now that can be slightly controversial in that you think that waste being burnt would produce more emissions, but some of the technology which is being developed with the machines at the moment, there's zero outputs in terms of emissions from the systems, but also that waste is not only just producing energy, but also producing byproducts such as which can be turned into building materials, for example.
My knowledge of AI plants in the UK, dairy farmers might use an anaerobic digestion system where scraping up all the cow poo, pulling it into a certain area, using a chemical process. There's still electrical power input required to run this process. So obviously you still got to put some form of energy in to get energy out. You're extracting gases off the AI plant, which is then burnt and turned into electrical power. Obviously, if you leave the cow poo on the field anyway, it's going to produce the same gases. You're speeding up that chemical process to harness the power when you need it. My knowledge of AI plants isn't massive, but I do know that they can be quite problematic, and they are very prone to break down due to there's lots of moving parts and lots of processes and sensors where they can go wrong.
Great. We've still got another 9 minutes before we wrap up. I'd like to mention at this point that you will all be receiving some survey questions. I'll urge you to fill them out so that the UK Ghana Chamber of Commerce is able to ensure that subsequent engagements like this one meet your expectations and leave you with enough knowledge to do awesome in your area of work. There are only 3 very simple questions, and they're in the polls and quizzes bit. So it's going to be popping up, and then you can answer them. So a few more questions coming in. Now, this is a follow-up to the 33-volt rated system. The question Kofi Abuaji is asking is that solution for 24 hours? Leigh, I think you answered that question earlier. In terms of time span, whether it's 6, 8, 20, or 24 hours, from what you've said so far, I believe this has to do largely with your storage capacity and how many solar arrays.
Yeah, obviously, the output of an off-grid solar battery system is going to be down to the design, how many solar panels, what size your battery arrays, what size inverters. So the answer is yes to anything technically possible. You can power off solar and batteries. But it's actually down to the design of it, how big your battery system is, how big your solar array is. So technically, yes, you can power anything you want. For most things, it's all about getting the design right.
Great. We have our very first Facebook question. And this Anthony Archery, coming straight from our Facebook stream, would like to know, how much is one solar PV installation? I guess from the little I've picked up so far, is dependent on what your needs are.
I think I covered it on my presentation earlier. Industry-wide standard throughout the whole world. Obviously, the larger scale system you go, the less you're going to pay. Scale of economy. You're roughly looking at $900 to $1,400 per 1,000 watts of solar panels installed. Now that is a grid connected solar system without batteries. When you're adding batteries, that's going to up the cost. So it really does depend on the size of the solar array or the solar system and whether you're having batteries or not.
Great. Thanks very much, Leigh, for that one. Jonas Wilmer is asking, says nice presentation, and that's true. His would like to know, how do I convert kilowatt hour to carbon savings?
I think I can take that. So with that, there's a roundabout way you can go about it, or the way I usually go about it is that there are carbon emission factors for various sources of energy. The unit of that is tons of carbon dioxide equivalent per kilowatt hours. You multiply that by whichever energy consumption you are talking about in kilowatt hours, and you'll be left with the tons of carbon dioxide emissions. So from those emissions, you can find out how much you'll be saving if the emissions are saved. I hope that answers Jonas's question. If not, you can just shoot a follow-up question and I'll answer for you. It's more technical, more calculated, but yeah.
Okay. Now, Stephen Yomo has a very important question, and I'm sure it's on the minds of most people when they want to venture into anything, which has to do with access to finance. Now, in Ghana, interest rates are quite high. I think the recently revised policy rate is somewhere in the region of 29.5%. So banks are obviously not a favorable option for most people. What other financing options, could you guys propose or that you've seen work elsewhere so that a lot more people are able to adopt solar? To look at the initial cost outlay. Mark,
Okay,
you were nodding.
Mark, okay. I think Mark
Yeah,
can
Mark
go
was
first, and then I'll
nodding,
just
so
add my.
yeah. Let's give Mark the shot this time, Mark.
Yes, I think rather than sort of going through the traditional finance means, should we say, there's a large appetite in the UK from financial investors, from venture capitalists, and also from pension funds. So many of the pension funds within the UK, which would have traditionally invested in some of the fossil fuel producing organizations, should we say, they're now looking to divest that investment into those type of organizations and direct funding into other areas and make investments in other areas. So we're finding a lot of interest from more sort of commercial funding organizations rather than banks.
Okay, solid points made. Now the issue of we talked about some of the low-hanging fruits. Now, one of the critical sectors of the Ghanaian economy, as with many evolving economies like ours, is that the micro to small and medium enterprise businesses are quite numerous. In Ghana, there's more than 85% of our registered businesses are sitting in that space. And so these are the people who are going to drive the future of our economy. What sort of hurdles, have you seen in other areas where you've worked that, businesses in that bracket will face in transitioning into renewable energy? Of course, one of the biggest challenges I can think of is access to finance. But beyond that, what would be a way to go to help these businesses ensure that they're not only sustainable, but they're efficient in using the available energy, renewable energy source? Leigh, Mark, Kofi. All right, let's go to Leigh then.
You're picking on me, are you?
Yes.
Okay, so I suppose really in essence is getting access to the people with knowledge, people who can offer you good quality equipment. I suppose one of the things I've seen in some countries is lack of education and awareness on how renewable energy can benefit them as a household or a business. So I think creating an awareness of how this technology works and how it's going to benefit people is going to be a big driver in the marketplace.
Right. See, I picked on the right person. Delivered very successfully. Well, gentlemen, I'd like to thank you all for your presentations. It's been spot on. I certainly I'm walking away with some new knowledge on the potential of renewable energy, particularly solar and wind. We didn't talk much about wind, but I mean, you've all attested to the fact that it's also an alternative source of power that abounds in these parts. Thank you to the UK GCC. Thank you to Kofi, Ayim Ayeko, who's a technical expert at AGI, the Energy Service Center. That's Association of Ghanaian Industries. And then also thank you to Mark Sanders-Barwick with ZPN Energy, and also Leigh Naylor with Off-Grid Installer. Please fill out the survey questions. There are just 3 of them. Yes, Sarah Adelaide is with the UK GCC, and she has a comment or some announcement to make. So Sarah Adelaide, I'm handing over to you.
This is just to say that this webinar has come about with direct sponsorship from the Department for Business and Trade, the UK's Department for Business and Trade, with Mr. Michael Taabavi, who is the infrastructure advisor leading directly on this. And would like to give him a few minutes to give us a short presentation, and then we can just wrap up. Thank you so much.
Thank you, Sarah Adelaide. So Michael, We're all ears, and you have the floor.
Thank you, Inshira. Thank you all for joining in this morning. It has been a really interesting discussion, getting the opportunity to listen to experts in the renewable energy space. And I'm really quite glad that we're able to let this happen. From the Department for the Department for Business and Trade, formerly Department for International Trade, we brought this about mainly due to the timing. We felt that the industry has been going through some challenges because of the current economic challenges, as well as the recent increase in the utility tariffs. We are talking about 30% increase in the utility tariffs. So we felt it would be beneficial to promote some of these energy solutions for the key and industry players. I hope everyone can see the screen now, so we can move on. I just want to touch on the Department for Business and Trade, just to let everyone know what we do. And for all those who are not currently aware of us, it's important to just touch on what we do. So basically, the department is a UK government arm that seeks to promote UK and global prosperity. And we are a global government arm of the UK government. In Ghana at the moment, we have advisors in 4 main sectors, being the infrastructure sector, energy sector, investment space, and then also within the education and digital space as well. The vision of the UK international trade is for global prosperity to ensure stability and security across all regions. And our mission is quite simple. We want to help business export from the UK to Ghana, and also from Ghana to the UK as well. We try as much as possible to drive both inward and outward investments. And in doing so, we help to navigate challenges that businesses face. For instance, some businesses face challenges establishing a footprint in Ghana and vice versa. So what the department does is we try as much as possible to get in touch with the businesses to find out their challenges, and then we help to address these through meetings and discussions at a very high level. We are also a very big champion of free trade, and as I'm sure most of you will be aware of the Africa Free Continental Trade Area, and we have a team that sits within the Accra that specifically handles that as well. Can we move on to the next slide, please? In terms of what we do, we support as much as possible, as I mentioned earlier, we support UK businesses get access to commercial opportunities. And we also serve as a mouthpiece for UK businesses operating in Ghana. So for instance, we have a large number of UK businesses in Ghana that try as much as possible to get in touch with us whenever they face some challenges. We also engage with policymakers to resolve market access issues, as I mentioned earlier. I think we can skip on to the next slide as well once I continue. So what we currently focus on is commercial opportunities. We try as much as possible to identify viable investment and development opportunities in the country, and then we promote those opportunities to our UK businesses that are interested in working in Ghana and Africa at large. Within the Africa continent, we have priority countries that we, as much as possible, promote UK businesses within. So we are able to liaise quite effectively with those businesses that are already established in the African continent and also want to transfer to Ghana as well. We connect these opportunities to the UK market, and we connect these opportunities between the UK market and the Ghanaian market, and then we provide support for them as well. We can move on to the next slide, please. Now, in doing our work, we try as much as possible to engage with both our internal and external partners. Within our internal space, we work very closely with the Trade and Economic Reform team. which is a very good team that has expertise within the economic space in Ghana. They have a very vast knowledge of the current economic trends at the moment. We also work quite closely with the UK Ghana Chamber of Commerce. As you have seen today, this has been a very good collaboration between the Department for Business and Trade and the UK Ghana Chamber of Commerce. We try as much as possible to do similar events and sessions like these to promote UK businesses and as well as educate the Ghanaian industry as well. I also mentioned somewhere within the presentation, I came in to talk about how we support investments in Ghana through the UK Export Finance and British International Investment. So these are investment arms of the UK government that help to promote investments within areas of interest. So within Ghana, we have the UK Export Finance that has guaranteed and provided investment opportunities for some of the major projects around. We also work quite closely with DBT teams across the African markets. So I mentioned there are some priority markets within the African continent in which Ghana is one. So we try as much as possible to connect businesses that are already operating in those priority markets with the Ghanaian market as well. We also work quite closely with the institutions within the UK government and the Ghanaian government, both private sectors and the public sector. I think if you would like to find out more about the department and what we do, it would be quite beneficial to get in touch with me directly. I've left my email address in the comments. I'll also include it in the emails that we'll be sending out to everyone. If there are any opportunities, anybody out there would like to share with us, we can bring it up for it. In terms of renewable energy, the areas that we try as much as possible to focus on are, as we've witnessed today, energy storage systems, onshore and offshore wind, where Ghana has very vast potential along our coastline and inland towards the mountainous areas. We also have a lot of focus on solar PV, and now currently we are working quite hard on promoting biomass and biofuels sources of energy. We also look into waste to energy sources as well, and our focus in these areas are as much as possible linked to what I mentioned earlier in terms of promoting UK-Ghana trade, contributing to Ghana's net zero ambitions, and contributing to our NDGs and SDGs that we've signed up onto. In all, we try as much as possible to contribute to a sustainable energy mix where we have a mix of renewable energy sources as well as our traditional energy sources, because it's important to have a very suitable and sustainable energy mix. We can't rely solely on renewable energies going forward. We need to have a very balanced mix where some of these energy sources may not be able to power completely. So this is what I just wanted to touch on briefly just before we end. And I would like to say a very big thank you to you, Inshira, and to UK Ghana Chamber of Commerce, as well as the AGI Service Center for this wonderful presentation we've had today. Back to you, Inshira.
Oh, thank you very much, Michael, and thanks for that presentation at the end. I'm sure that will generate its own set of questions. In fact, we have one from Kofi who's asking, how do we register with your organization? I'm not sure. I think there's the UK GCC would be the registration point. Is there anyone who would take that?
Okay. So I don't quite get the question in terms of
how do we register with your organization? So I think the membership would be UK GCC, not with the.
Yes. So with membership, you can contact the UK Ghana Chamber of Commerce for registration if you want to join the chamber. In terms of contacting the Department for Business and Trade, you can send me an email and we can talk about what exactly your needs are, and then we can address it from there directly. You don't need to register with the department. You can contact us and then we can take it from there.
Thank you very much for that clarification. And it's exactly 12 o'clock. And that means we're at the end of this very important energy webinar. Again, thank you to the team at UKGCC, and the Department of Business for making this possible. Thank you to Leigh. Thank you to Mark. Thank you to Michael, and of course to Kofi with all the presentation. And with that, I bid you all good day. And please do well to reach out to the UK Ghana Chamber of Commerce. They're available on Facebook and also on Instagram. On Facebook is UK-Ghana Chamber of Commerce. And you can also send an email to info@ukgcc.com.gh, and they'll be very happy to help you and guide you in the right direction. Have a good day, everyone, and stay safe. And thank you. God bless you.
Thanks very much.
Take care, guys.
Thank you.
Thank you all.
Thank
Bye.
you. Bye.
Thank you.
Thank you. Bye.